morning, friends. I am Dr. Yagya Dutta Dwivedhi, professor from Institute of Aeronautical Engineering. I am in the process of covering the flight mechanics. Today, I will be covering this topic, that is problem solving on analysis of takeoff and the landing performance. In today's, we have the topics: revision of takeoff and landing, minimum control speed, calculate the ground roll, thrust required for a takeoff ground roll. So we have this some landing and the takeoff performance, some revisions I will take here. For the takeoff, the initial it is V is equal to 0, and this is here up to, it is a ground roll, and then it is for the takeoff, it is from here, it will come for the landing, it will be here, velocity will be 0. This is the V touchdown, this is the V approach. Same way for the takeoff, it is V lift off, then it is roll here, it is, so different ways are there. So here you can see here that brake release and SG, it is a ground, then it is a rotation begins here, then it is a S small g, then it is SA, rotation ends, and clearing, it is a lift off from here. SR, SA and SG. Total STO is equal to SG, that is ground roll, plus rotation, that is SR plus SA. And here are some velocity parameters are mentioned. Detail of takeoff operation for a conventional aircraft. So how much ground roll start, in all these parameters are here. And these are the two aircraft which are shown here. It is during the landing. This is the landing. And this is the takeoff. So now I will go for the problem which I am concerned with. The transport aircraft shown in figure 8.6. 8.6 has twin turbofan engine, each generating 170 kilonewton of thrust. The distance between each engine thrust line and the aircraft center of gravity is 12 meters, and the distance between the vertical tail aerodynamic center and the aircraft center of gravity is 42 meters. If the maximum lift coefficient of the vertical tail is 0.9 and the vertical tail area is 40 meters square, determine the minimum control speed of this aircraft at sea level. So this we will see here, that this is the aircraft here which is given. Okay, so this is the aircraft, and in this the vertical distance, the horizontal, this all parameters are given here. So we know that NCG is equal to 0. So T lift into LT is equal to L lift into LVT, where L is the vertical distance, LVT, and it is a horizontal distance. So LVT is equal to T lift into LT divided by LVT. So just we want to find out this VT. LVT. So this LVT, it is given that T lift is 170 into 1000 into LT is equal to 12 divided by 42. You will get 48571 Newton. So LVT. This much force need to be developed. The minimum control speed, can be determined from the following vertical lift equation. So LVT is equal to half rho V square, half rho V square MC into SVT into CL max VT. So VMC is equal to under root 2 into LVT divided by rho SVT into CL max VT. So all the values 2 into 4, 8, 5 which we have just find out here. 7, 1 divided by rho is 1.225 into 40 S into 0.9. So this VMC is equal to 46.93 meter per second or 91.24 knot. So this is the answer for this problem. Now we will go for the next, that is the problem number 2. This is the problem number 2. A transport aircraft with a takeoff mass of 150 kg has a wing area of 280 meters square. The aircraft cruising speed at 25,000 feet is 525 knot, and the relation between engine thrust in pound and the airspeed in feet is as follows. T is equal to 0.1 V square minus 90 V plus 9,200. Other characteristics of the aircrafts are given. K is equal to 0.05. CD naught takeoff. It is takeoff 0.055. CL of the flap is 0. That is no flap deflection during takeoff. VS stall speed is 105 knot. And VR is equal to 1.3 VS. Determine the ground roll if the runway is dry and dry concrete. So these are the few parameters which we have given. So we have to determine SG, that is the ground roll distance. So we will start now the given parameter. Mass is given, M is equal to 150,000 kg. Area S is equal to 280 meter square. V CR is equal to 525 knot at 25,000 feet. Thrust is equal to given as per V square minus 90V plus 9200. K is equal to 0.05. CD naught is equal to takeoff is equal to 0.055. Delta CL lift off is equal to 0, no flap. VS is equal to 100 knot. Find ground roll. And we know that we have to find out at at 25,000 feet, rho is equal to 0.55 kg per meter cube. From the table we have to find out. So now CLC is equal to 2 mg divided by rho VC square into S, 2 into 150,000 into 9.81 divided by rho is equal to 0.55. VC is equal to 525 into 0.5144. To convert knots to meter per second, we have to multiply 0.5144 and CL area is equal to 280. So CLC 0.262. Now we can find out the CLTD, means takeoff. Touchdown is equal to CLC plus delta CL lift flap. This is 0. So this will be the same, 0.262 plus 0, 0.262. Now CD takeoff is equal to CD naught of takeoff plus K CL square of takeoff. CD naught is given 0.055 plus 0.04 into 0.262 square. So this you will get 0.0584. So we got now CL and CD, and we know the equation for this ground roll SG is 0 to VG MV divided by T minus mu mg minus half rho V square S CD naught takeoff minus mu CL takeoff into dV. And from here we can find out that this thing, so CD naught takeoff minus mu CL takeoff, so 0.0584 minus mu is 0.02 for the concrete, and then we have 0.262 CL. So we will get this value as 0.05316, and VR it is given as a 1.3 Vs, and Vs we know it is given 1.3 into 105 into 1.688. So here we will get 230.2 feet per second. We got this VR also. So now we will see the next, that we know that 1 kg is equal to 0.0683 slug, and 1 meter square is equal to 0.929 feet square. So mu mg we can find out that 0.02 into 150,000 into 0.0683 into 32.2. It is a Z. So this we got here 660 pounds. So we got mu mg, we got this, all the things we have. Now we will put in the equation SG is equal to 0 to VG MV divided by T minus mu mg minus half rho V square S CD naught takeoff minus mu CL takeoff into dV. So now we will put 0 to 230.2, 150,000 into 0.0683 V dV divided by 0.1 V square minus 90 V plus 92,000 minus 660 minus 0.03091 square V square 0.05316. So you will get SG is equal to 370 feet. So this is the answer for the problem. So now we will see the next problem, that is the problem number 4. This is the problem number 4. A jet transport aircraft similar to Boeing 737 with a takeoff mass of 50,000 kg has a wing area of 120 meters square. Other characteristics of the aircrafts are Tmax is equal to 130 kilonauts, CLC is equal to 0.2, K is equal to 0.04, CD naught takeoff is equal to 0.05, delta CL flap is equal to 0.3, Vs is equal to 110 knots, VR is equal to 1.2 Vs. Determine the takeoff ground roll, runway strength and all. So here we will see that the takeoff, lift and drag coefficient. So CL takeoff is equal to CLC plus delta CL flap. So 0.2 plus 0.3 it is equal to 0.5. Now CD of takeoff is equal to CD naught of takeoff plus KCL square of takeoff. CD naught is 0.05 plus 0.04K into 0.5 square. You will get 0.06. Now, a no slope condition. No slope condition. This Sg is equal to 0 to Vg mv T minus mu mg minus half rho v square s CD naught takeoff CD takeoff minus mu CL takeoff into dV. So we have to find out CD takeoff minus mu CL takeoff, and we can get it 0.06 minus 0.04 minus 0.5. You would get 0.04. Vg is equal to 1.2 Vs. 1.2 into 110, it is 67.91 meter per second, and mu mg is equal to 0.04 into 50,000 into 9.81. You will get 70. You will get 19613 Newton. Half rho s is equal to half into 1.225. S is 120, 73.53 kg per meter. Thrust is equal to 0.9 T max. 0.9 into T max is 130 into 3. So 117,000 Newton. So this is the thrust. Now we can get the Sg. 0 to 67.91. 5,000 V into dV divided by 117,000 minus 19613 minus 73.13 V square into 0.04. So this Sg is equal to 1275 meter. So this is the answer for the problem which we have just now understood. And if we take about the positive slope, then Sg you have to find out. And same way you have to calculate, and you will get 2421 meter. And if it is a negative slope, then we will get this 5,000. This mu mg will be here positive. So this will be reduced to 865 meter. So for positive slope will cease to a 90% increase in ground roll. With a negative slope, 95% will be case, 32% decrease in ground roll distance. So for the negative case, 32% decrease in ground roll distance is experienced. So this is the last problem for this. Using average acceleration method, find the maximum power takeoff ground run with no wind and a zero runway slope for a 6,000 kg T-38 at sea level and 6,000 feet given the following conditions. Wing area is 15.8 meter square, CL maximum is 0.88, mu r is equal to 0.025, CD naught is equal to this, T average is equal to this. So we have to find out that CL is equal to mu r divided by 2K. So 0.025, 2 into 0.2, you will get 0.0625. Now CD average, we will get CD naught plus KCl square max. So CD naught is 0.02 plus 0.2K. CL max is 0.0625 square. You will get 0.0208. And we know that Q average is equal to half rho V square average, and acceleration is equal to G by W, T average minus D average minus mu R, W minus L average. So if you put this value 9.81 divided by 6000, T average is 6000 minus D average we can find out, and by D average half rho V square S CD. This D you can put here. L is equal to half rho V square S. You will get the CL. This you will get the lift. And so in this way you can find out the velocity. Vs is equal to 2 into 6000 into 9.81 divided by 1.225, 15.8, 0.625. So you will get this value, and put this all value, all the solutions will get it. So these are the references which we have taken. Sadre, Aircraft Performance and Engineering Approach, CRC Press. Anderson JD Junior, Aircraft Performance and Design, International Edition, McGraw Hills. Any questions you can ask to me in yddwivedhi@gmail.com. Please do like and subscribe my channel. Till then, goodbye. See you again for my next lecture.
Like, share and subscribe. Hit the bell icon for more updates.